In this video, we are going to report the most experienced employees in each project. Hello, this is Jagan from Growth Data. I am posting this video to share my knowledge in SQL with you. If this assists you in your interview preparation anyways, I will be happy. Welcome to the 43rd video of our Advanced SQL 15 interview question series. We covered few topics now and we are in the last topic of the series, CTE and the Windows function. The CTE means common table expression. We have seen few examples before. Now we are going to focus mainly onto the CTE and the Windows function. This video will be tagged in Advanced SQL 50 questions playlist and the code we discuss in this video will be uploaded to the GitHub. The link for the GitHub page will be in the video description part. Now let's see the data set and we can talk about the question in detail. So we are given two tables here. One is the project, the other one is the employees table. So the project table got the project ID and the employees involved in that project. And the second table, the employee gives the employee information like the employee name and the years of experience with that employee. So if I have the employee ID, I can get the name and the years of experience from this table. So given this data, what they're asking us to do is we have to report the most experienced employees in each project. If there are more than one employee with the same experience, then we have to report all the employees. Let's create the table first. Now, if you see this data, here for the project 1, we got 3 employees and for project 2, we got 2 employees. So for the first one, the employee 1, his name is Khalid and he got 3 years of experience. And the second one is for same project, the name is Ali and got 2 years of experience. And for third one, the name is going to be John and got 3 years of experience. The same employee 1 is in the next project also. So he is running 2 projects. And finally, the employee 4 who is Doe who got 2 years of experience. So given this data, if you see this, first 3 is the project 1 and second record is the project 2. So given this scenario, if you see the years of experience 3, 2 and 3. So the most experienced person is Khalid and we can get John also because both are 3. If you go to project 2, we got 2 employees and we got years of experience 3 and 2. So 3 is the winner. So consider this scenario. For project 1, we got 2 employees 1 and 3. For project 2, it's straightforward. We got 1 employee. So the expected output is going to be for each project what is going to be the project employee ID. So you can give the employee name also if you want. Okay, now how to do that? We have done the similar examples before, so we can do it in different ways, right? We can use a CTE table, we can use a subquery table, we can use a correlated subquery, we can use concatenation, Windows function, and much more. So we can go in this pattern. First we see the CTE table and then we see how to use the subquery table and how the correlated subquery works, and then we can concatenate the values and check finally the Windows function. These are the 5 approach we are going to see in this table. First we start with the CTE table. So here what we have to do, first we have to find for every project the employee and how many years of experience and get the max out of it. So for reference, we have to first get the project or the employee say experience, right? So we get the maximum experience for every project and then we can compare this. So we start with the simple query. Select from the project table, say P, inner join employee E. So both are connected with the employee ID. employee ID equal to p dot employee ID. So I connect the project table with the employee table. Now what I am going to do is I am going to get the for every project, right? So for every project, for 1 and 2, what is the maximum age? So I get the project ID from here, p dot project ID, and then we say max of the employees experience years as max RE XP or experience years. So since we use the aggregate function, we have to use the group by group by product ID. So now if I run this for every project 1 and 2, what is the maximum the experience available? So for 1 we got 3 and 3, right? And for 2 we got 3 years of experience. So considering this as a data set, you can say with raw data as, so we keep this data set and then using this data set we will filter only the maximum experienced employees. So the same code I am going to use, let's say get the project ID and the employee ID. Instead of this I say p dot employee ID. The connection is going to be the same. So instead of group by, I just again inner join the raw data as src on src dot the project ID, right? src dot project ID equal to p dot project ID, and then the xrc dot maximum experience years should be same like the employee dot experience years, right? So first we'll have the project ID and the employee, and then we make sure those employees salary is equal to the maximum salary we get from the CTE table, right? So when you run this, you get for project ID 1 we got 1 and 3. So where are we in project employee or data project maximum experience equal to E dot experience years. Oh, it's the employee ID. So 1 3. Okay. So 1 3 1. So if you want to get the employee name, so instead of the employee ID, we can simply say E dot name. So that will give you the employee name. Years of experience you can add to it however you want to. So this CTE table first get for every project what is the maximum experience we get, and then we filter out those experience from the normal connection, right? You do get the project ID and the employee ID and make sure their project matches with the maximum experience years. That's done. So this is the CT table, and I always say CT table, the main usage is you have to use multiple times in this query, then it's a useful thing. If not, then using CT logic. The second option is going to be the subquery table. Let's comment this out. Go up and do subquery table. Subquery table is nothing but you get the CT logic and instead of calling the CTE table, you just put that in place of it. So here inside the CTE table, this will call the SQL and store the data. We just have a format so we understand this. So here this query will run and store the data within this src variable, right? It just stores here, and then we compare the same thing. If I run this, I get the same result. So here I can just add the employee name e dot name, so you get the name, but the required thing is the project ID and the employee ID. So we got the result. So the structure is going to be the same. So instead of explicitly saying that you store it in a temp table and then you use it, we directly running it. So both are the same. The only thing is, if you have this kind of subquery table, we can't reference this in the next query. If you have one or two sub part of the query, then we can't use it. But for CT table, you can just use the same data set in multiple SQL steps. Okay, so we covered the second option, subquery table. The next one we are going to see is the correlated subquery. So what is the difference between the subquery table or the subquery and the correlated subquery? Subquery table is, instead of a table name, we just put a SQL so that it will store those data in that particular namespace. When you say correlated subquery, you can go with the subquery which is independent of the other things, like project and employee connection will run by itself, and then this subquery table will run by itself, right? There is no control between it. So everything will have their own data set, and then they join and then they get the data based on the filter. The next one we see is a correlate subquery, which is the main difference between the correlate subquery and subquery is correlated subquery depends on the outer table. So based on every record in the outer table, the correlated subquery will trigger. Let's see how to do that. So we get this structure the same. So instead of this subquery table, we are going to trigger a condition and e dot experience years, right? So we just connect with the experience years, right? So that one you're going to get from here equal to select project ID maximum of this. We don't need the project, so we just say the experience year should be the maximum of experience year from the project table. You can say pp, where the pp dot project ID, right? So every project ID should be depend on this main table p dot project ID. So what happens here? For every project ID triggers here, it will go into the subquery and just get the maximum experience, and then see if that experience here is matching with the main table's experience here. If matches, then it brings the data. So if you see this, we said call it, we have duplicates here. So you got project ID equal to project ID, and then the experience equal to select max of experience for project, where project ID equal to project ID. So we got for project ID, nothing is filtered out. So something is missing in the filtering part. Your project ID, employee ID, from project, the employee ID equal to employee ID, and years of experience equal to select max of E dot, right? We just say E dot, so it just brings here. Oh, we haven't put the experience here itself, so we just the confusion. So PP inner join the employee can say EE on EE dot the employee ID equal to PP dot the employee ID. So we connect with the project and the employee and get the subquery experience years, and then we control the project ID based on the top query. Now if you run this, you got the filter. So whenever you are writing the column, you make sure you connect only with the columns corresponding to the subquery table. If you put E, then it will match with all the records in this, so you don't get the expected result, right? So you get all the records because we are connecting the E dot experience here, so it always matches with all the conditions. So E dot experience here equal to E dot experience here, one equal to one kind of thing. So you make sure you have the right alias name, right? So that works. This is correlated subquery. The next one we are going to see is, instead of experience year and then the project ID goes separate, we are going to concatenate those. Correlated subquery. So how will we concatenate this? This is going to be a pure subquery part of it. Concatenation. So here what I'm going to do, instead of getting the condition and the experience is separate, we just say get the project ID and the experience which is going to be similar to this project ID and the max of it. Let's comment this out. So get the project ID and the maximum experience PP dot and the maximum experience part from this and this. So we are now going to control with the upper query, right? So you can move a little bit here. So this is purely a subquery, but the project ID and the experience, right? So this should match with the concatenation of the outer table. So if you run this, it's throwing error, non-aggregate function. So we did max, we haven't done the group by. So now the second experience subquery, it has more than one rows. So here equal to, right? It's equal to, and this is going to give for every project ID one record. So the equal to is going to throw an error. So it's a in class. So this will create the two records, right? Every project ID get the maximum experience. So two records, if you say equal to, so one equal to two records, which is going to throw an error. So you put the in class. Now if you run it, you get the expected result. The next one is the our favorite, which is the Windows function. So let's start with the main join. So here we have the project ID, employee ID, name. Let's start with the row number. Row number over partition by p dot project ID. as check. So if I run this, for every project ID and employee, it just creates a number because there is no condition for which one should come first. So what I'm going to do is order by the experience, e dot experience years. So if I do this, let's bring in the, instead of name, I can just say experience years. So if I run this, we see the experience 233, right? So 233, we just say 1, 2, 3. So based on the order, it just brings in. If we put employee ID as a second option, then the row number will be based on that order. But we need all the employees who got the maximum salary. More than one employee got the maximum salary, you have to bring both, right? So the condition here is the employee 1 and employee 3 got the same salary. So for project 1, employee 1 and 3 has to come. But when you put a row number, you just put a order sequence 1, 2, 3, 4. So what I do a rank. When I do a rank function, if I run it, so the rank will put 1, 2 and 3. But I need the experience, max experience as the first one, right? I need only the top experience people. So order by e dot experience years, descending order. That will give me the maximum experience as 1, and then what happened to 2? Because the rank will skip the sequence. If there is more than one record which has the same rank, the next rank will be skipped. If there is 3, like 1, 1, 1, like 3 records are the 1 and then goes to 4. So there is no sequence of it. In this scenario, we need only the first or the top experience salary, so 1 is fine. But if you want to get the top 3, right, then the rank is not going to work. In this scenario it works, but not the in generic form. So you say dense rank, it's same like rank, but the sequence will be maintained. Even if I have 2 records in one, the next sequence is going to be 2, 3, 4 like that. So I prefer to use the dense rank. And I always say in the database like Teradata or Snowflake, you can simply say qualify check equal to 1 works. But MySQL, we don't have that. So what I do, I just create a CTE table with raw data as. Now I can bring in whatever the column I need. You can just say PP and P because it's going to be from one CTE table. So the filter condition is where the check equal to 1. So select spelling mistake. So it just filters out only those employees who got the maximum salary, right? This check filter works here. So this is the difference between row number, rank and dense rank. These kind of scenarios for top 2, top 3, better you always go with the dense rank. If there is no condition, just put a sequence of it, then you go with the row number. Okay, if you want to practice all this code, then it will be in the GitHub page, and this video will be in Advanced SQL 50 questions playlist, and the description part you have the GitHub link which take you to the code base. So the current video we are talking about 43rd video. So that will have the create statement of project and the employees and what is expected, and the 4 approaches: the CT table, subquery table, correlate subquery, concatenation part, and finally the Windows function with the dense rank. So all the 5 approaches are here. You can use this for your practice. If you want to join the WhatsApp channel, then there's a link here. You can use this and join Grow with Data WhatsApp channel. I'll put some short videos and snippets in this group. If you like to watch, you can just follow this. Hope you like this video and thanks for watching.